So good afternoon, students. Am I visible and audible to you all? Can you see me? Am I visible? Hello. Okay, okay. So, hello everyone. Myself Anandi, and today I'm going to deal with the question discussion on the topic aromatic compounds. Okay. We'll wait for 2 more minutes. Okay. Okay, let's start the class now. So the first question for today's session is, aniline is prepared in presence of Fe and HCl from. So what is aniline? What is the formula for aniline? So it is C6H5 NH2, right? So C6H5 NH2. So this aniline is prepared from which compound using this Fe and HCl they are asking. So what is the thing? You might have studied this. So reduction, these are the reducing agents. Reduction of nitrobenzene leads to aniline. Okay, what is the formula for nitrobenzene? It is C6H5NO2. It is C6H5NO2. So this is nitrobenzene. So nitrobenzene on reduction gives aniline. So what is reduction basically? Reduction is the removal of oxygen or addition of hydrogen, right? This equation is given there in your book and in the modules also. It's a straightforward question only. So the answer is nitrobenzene. Okay, answer is nitrobenzene. So now we'll move on to the next question. Do you have any doubt here in this question? Or anybody wants to ask anything here? Is this clear to everyone? Okay, fine. I'll move on to the next question. Benzene reacts with CH3Cl in the presence of anhydrous AlCl3 to form. So this reaction is one of the electrophilic aromatic substitution reaction, right? So we do have 5 electrophilic substitution reactions called halogenation, nitration, sulfonation, Friedel-Crafts alkylation and Friedel-Crafts acylation, right? So here the CH3Cl in presence of anhydrous AlCl3, this comes under which aromatic substitution? So this is the example for Friedel-Crafts alkylation. Okay. First we'll take a benzene. Benzene on reaction with CH3Cl in presence of anhydrous AlCl3. So this is the electrophilic reagent, and the electrophile that is being generated from this reagent is the CH3 plus, right? So this is the methyl halide part, and the methyl group is the electrophile, which is the alkyl group. And this electrophile will go and get substituted in the benzene ring. So at last, what do we get? We'll get phenyl ring attached to CH3. Okay. So which is nothing but the methyl benzene, and the other name for methyl benzene is toluene. Another name for methyl benzene is toluene. So the answer is option 1. So benzene reacts with these reagents to form toluene. Is this clear to everyone? We have any doubts over here? Can you type S or it's clear so that I can see? Okay, fine. Okay, fine. Okay, fine. So Ashika, can you hear me? Ashika? Okay, no problem. We'll move on to the third question. Among the following 4 compounds, the acidity order is. So 4 compounds are given: phenol, paramethylphenol, metanitrophenol, and paranitrophenol. And we are asked to find out the acidity order for these all the 4 compounds. Okay, so let's draw the structure of all these 4 compounds first. What is the structure of phenol? It is C6H5OH. Okay, and the paramethylphenol is, first draw the phenol, and in the para position means which is opposite to this OH. In the para position, you have to add one methyl group. So this is the paramethylphenol. And metanitrophenol. So draw the phenol again. And in the meta position, you have to attach one nitro group. What is meta position? Meta position is the alternative position to this group. So which is alternative to this? And this position is alternative to this OH. And you have to attach NO2 here. And this is metanitrophenol. And the fourth compound is paranitrophenol. So para means again the opposite position to this OH. To the opposite, you add this nitro group, NO2 group. Okay, this is paranitrophenol. So among these 4 compounds, this is compound number 1, and this is compound number 2, this is compound number 3, and this is compound number 4. Okay, now we are asked to find out the acidity, right? So how to find out this thing? Acidity means electron deficient species. Electron deficient species are called as acids or acidic compounds. So how to find out whether a particular compound is acidic here? For aromatic compound, how will you find out? So we can find out from the groups that is being attached here. So in case of phenol, we have only OH group attached to the ring and no other substituents are there. And in case of second compound, methyl group is attached. So methyl group is electron releasing group. It is an electron donating group. Okay. And what about NO2 group? Is it electron donating or electron withdrawing? It is electron withdrawing group. And again, here also the same thing. NO2 group is an electron withdrawing. When the group withdraws the electron from the ring becomes more electron deficient and it becomes acidic. Okay. Now you see here, first we'll come to this third compound and fourth compound because there only we are having the electron withdrawing group. In case of third compound, nitro group is attached in the meta position. You would have studied this in your class. Introducing electron withdrawing group in the meta position has no effect of this acidic nature. Okay, they'll not withdraw the electron more effectively when it is attached in the meta position, as the electrons are not getting delocalized over there in the meta position. Whereas in case of ortho and para, negative charge is delocalized through resonance, and attaching the electron withdrawing group on the ortho and para decreases the electron density on the ring, which becomes more acidic. So fourth compound is more acidic. Fourth compound is more acidic. Then comes the third compound. Okay. And coming to this first compound and second compound, if you see, here we don't have any electron releasing groups. But in case of second compound, we do have electron releasing groups. Here already it is an electron rich species and CH3 group is making this ring more electron rich. Means it is more basic, right? So it goes at last. So compound 2 will come at last and before that phenol will come. Is this clear to everyone? Is this clear to everyone? Just say a yes or type something so that I'll come to know that you have understood. Okay. Okay, no problem. Fine. We'll move on to the fourth question then. So here, which is the answer? Option 1 is the correct answer for this question. Clear? Now we'll go for the next question. Question number 4. Which of the following compounds undergoes nucleophilic substitution reaction more easily? Nucleophilic substitution. What are nucleophiles? Nucleophiles are electron-rich species. If an electron-rich species has to approach another compound, another compound should be an electron-deficient one, right? So we have to find out the electron-deficient compound from the given 4 options. So how to find out the electron-deficient species? So again the same concept, electron donating and electron withdrawing capacity of the attached groups. So see here in the first option, we have NO2 group, which is an electron withdrawing group, makes the ring more electron deficient again. So it is more electrophilic in nature. Okay. Coming to the second option, we have CH3 group attached in the para position to this chlorine. So CH3 is an electron releasing or electron withdrawing? It is an electron releasing group or electron donating group, right? So it will donate the electron. So it is not that much electrophilic, it is nucleophilic. So this cannot be the thing. It is nucleophilic in nature. Nucleophile cannot approach another nucleophile. So this will not be the answer. And OCH3. OCH3 is again an electron releasing group. OR. OR, right? OR group is an alkoxy group. OR group is an alkoxy group. So alkoxy groups are basically, sorry, they are electron releasing group and again it makes the ring more electron rich in nature. So it is again nucleophilic. Okay. And here in the fourth option, we don't have any such electron withdrawing or electron releasing group. So it is a kind of neutral kind of thing. Okay. Now, comparing compound 1 and compound 4, which is more electrophilic? Compound 1 is more electrophilic because of the presence of this NO2 group. So, an electron-rich nucleophile can easily approach this electrophile and the reaction occurs most easily. So, option 1 is the correct answer. Clear? Electrophile reacts with the nucleophile. That is the concept. Electrophile reacts with the nucleophile. So I think this is clear to everyone. Now we'll move on to the next question. Question number 5. So among the following compounds, the one that is most reactive towards electrophilic nitration. The one that is more reactive towards, electrophilic nitration is. Option 1 is benzoic acid, 2 is nitrobenzene, 3 is toluene, and 4 is benzene. For electrophilic nitration, what is nitration first of all? Compound A will be there, an aromatic compound will be there. Nitration, who are the nitrating mixtures? It is concentrated HNO3 and concentrated H2SO4, right? So this is the nitrating mixture. And from this, we'll get an electrophile, which is called as NO2 plus. This is the electrophile that is getting generated from this nitrating mixture. And this electrophile will go and substitute one of the options given here. Now, which is more reactive towards this electrophilic nitration? So this is basically an electrophilic substitution reaction again. So for an electrophile to get substituted, the compound should be nucleophilic in nature, right? It should be more electron rich. So we'll draw, let me draw the structure of all the 4 compounds given here. So first it is benzene benzoic acid, C6H5COOH. And the second compound is nitrobenzene. So NO2 group attached to the ring. And the third compound is toluene. C6H5CH3 is toluene. And the fourth option is benzene. So this is benzene. Okay. Now, electrophile is going to get substituted here in one of the four compounds. Means the compound should be more nucleophilic in nature. Nucleophilic means the compound should be more nucleophilic means what is the meaning? The compound should be more electron rich. Again, the same concept we have to use here. COOH group is given in the first option. Carboxylic acid group is an electron withdrawing group from the ring. So it makes the ring more electrophilic. It doesn't make the ring nucleophilic. The system is electrophilic in nature. Again, the same thing occurs with NO2 group. NO2 is again an electron withdrawing group which withdraws the electron and makes the ring more electrophilic. Here CH3 is an electron donating group which makes the system more nucleophilic in nature. Here benzene we have, and here the attached atom is hydrogen. Okay, neither donates nor withdraws the electron, just the ring, it is benzene. When we compare these two compounds, toluene is more nucleophilic in nature. So this NO2 plus electrophile can approach this nucleophile more easily, and the toluene is more reactive towards electrophilic nitration. Is this clear? So option 3, toluene is the correct answer for this question. Did you all get it? Can we move on to the next question? This clear to everyone? Fine. We'll move on to the question number 6. An organic compound C3H9N, that is compound A, when treated with nitrous acid, gave an alcohol and N2 gas was evolved. And then compound A on warming with CHCl3 and caustic potash gave C, which on reduction gave isopropyl methylamine. Predict the structure of A. So here in the given four options, the formula of all the four compounds is the C3H9N only. They are all the isomers. Now we have to check one by one. Okay, first let's take this option 1 and check with it. So this is the given compound. When this compound, when CH3, CH, CH3 and NH2, when this compound, when the compound A, if it is A, when it is treated with nitrous acid, what is nitrous acid mixture? It is NaNO2 plus HCl mixture. So this is nitrous acid mixture. And at low temperature, this nitrous acid mixture will convert this NH2 group to OH group. Okay, it will convert this NH2 group to OH group so that we get an alcohol like this with the evolution of nitrogen gas. Got it? And the same compound A on warming with CHCl3. CHCl3 is chloroform, CHCl3 and caustic potash. Caustic potash means it is the potassium hydroxide. Okay, potassium hydroxide. And when this compound A on reaction with this chloroform and caustic potash, it is giving compound C. Okay. So what is the reaction basically here? So this is the name of this reaction is carbylamine reaction, right? So chloroform with KOH on primary amine, they gives isocyanide. So what is the compound we get from here? We get an isocyanide. So all these are CH3, CH3. Okay. Isocyanide is NC. So isocyanide we get, and this is compound C. And this compound C on reduction gave isopropyl methylamine. So this compound C on reduction gave isopropyl methyl. So for the reducing purpose, for reduction, we can use lithium aluminum hydride or catalytic hydrogenation. I think we can use, let me use this lithium aluminum hydride. On reduction, this will form the secondary amine. Reduction is addition of hydrogen, right? So it will form the secondary amine. So it is CH, CH3, CH3, and we'll get a secondary amine. Means here we'll have NH, and this will be converted to CH. So this is the process that is occurring in option 1, first compound. Okay. So what is the name of this compound? So it is N-methyl or isopropyl methyl amine. So this group is called as isopropyl group, and this is methyl group, and this is the amine. So we are getting isopropyl methyl amine from the first compound. Okay. So from the first compound. So option 1 is the correct answer. You can check with compound number 2, 3, and 4. Normally, this compound 2 and 3 cannot be the answer because in compound 2, we have NH. NH means it is secondary amine. NH is the secondary amine. This is the secondary amine. This will not undergo this carbyl-amine reaction, will not get cyanide, isocyanide, and again that cannot get reduced. And tertiary amine also will not react. So N is attached to 3 alkyl groups, right? So it is a tertiary amine. Tertiary amine also will not react with the CHCl3 and KOH. So will not get the product. Okay. So again, this fourth compound is a primary amine. You can check with this. If the amine is primary, will not get isopropyl, will get N-propyl methylamine. Okay. So, but they are asking for isopropyl methylamine. So from option 1 only will get the isopropyl methylamine. So that is the answer. Okay. I hope this is clear to everyone. I'll move on to the question number 7. So C6H5N2BF4 compound is given. Diazonium salt. It is a diazonium salt. And this diazonium salt on heating gives compound A. And we have to find out the product A from the given process. We have to find out whether it is fluorobenzene or benzene, or we'll get 1,4-difluorobenzene or 1,3-difluorobenzene. So what is the reaction here? So basically this C6H5, this N2 plus and BF4 minus. This compound on heating, it is an example for decomposition reaction. The byproducts from this reaction are BF3. BF3 will come out and nitrogen gas will come out as a gas. And we are having one more fluorine here, right? So that fluorine will go and get substituted in the ring. So this is the reaction basically. So what is the name of this product? It is our fluorobenzene. So we are getting fluorobenzene on decomposition of this C6H5N2BF4 minus. So it is given in option 1. That is the correct answer. Okay. Now moving on to question number 8. Which of the following can be used as the halide component for Friedel-Crafts reaction? So normally we have 2 different types of Friedel-Crafts reaction. One is Friedel-Crafts alkylation. The other one is Friedel-Crafts acylation. Okay. So in Friedel-Crafts alkylation, we use RX plus anhydrous AlCl3 or FeCl3 kind of thing. And in case of acylation, we'll have RC double bond OX plus the same anhydrous AlCl3. Okay. So which is used as a halide component for Friedel-Crafts reaction they are asking. Means they are asking the alkyl halide component. So Rx we have to find out. So Rx, who is this Rx? Alkyl halide. The first option you see it is isopropyl chlorine. What is isopropyl chlorine? CH3 CH bond, CH3, this is an isopropyl group, and Cl is attached here, this is isopropyl. And the compound number 2 is chlorobenzene. So this is an aromatic compound, right? This is an aromatic compound. This is not the alkyl part. So this is not the alkyl halide. Bromobenzene also same thing. That will not be an alkyl halide part. And chloroethene. So ethene is CH2 double bond CH2, and when you replace one of the hydrogen with one Cl, you will get chloroethene. Again, this is not the alkyl part. Okay. We should have the alkyl part R group. This is the R group, and this is the alkyl part, and isopropyl chloride is the alkyl halide component for Friedel-Crafts reaction. So option 1 is the correct answer for this question. Got it? Now let's move on to question number 9. In pyrrole, the pyrrole structure is given here. The electron density is maximum on. So 5 different atoms are labeled from 1 to 5 here, and we have to find out on which carbon atom the electron density is going to be more. Okay, so how to find out? So nitrogen is having 3 bond pair, and the valence electron for nitrogen is 5. It is already 3 electrons is already bonded, and we have 2 electrons present here as lone pair. And this lone pair shifts here, and the pi electrons will go here. So resonance occurs basically. When it goes here, the electron density on the second carbon increases. Likewise, in the same way, nitrogen lone pair can shift this side also. That time what happens? The electron density on carbon 5 also increases. So basically, the electron density is maximum on carbon number 2 and carbon number 5. Okay, and 3 and 4, they are very far away from the nitrogen, so the electron density will not be more on those 3 atoms. So it is more on carbon number 2 and carbon number 5. So option 1 is the answer for this question. Got it? The atom which is nearest to the lone pair containing atom will have more electron density. That is the concept. And coming to the 10th question, the compound that is most difficult to protonate is. What is protonation? Attacking of H plus ion. So who will attack the H plus ion? Will attack the proton. The lone pair electrons will attack the protons generally, right? So here 4 options are given. So in all the options, this OH group is constant and the left side group is changing. In the first option, phenyl is given. In the second option, hydrogen is given. The third option, CH3 is given. And in fourth option also, CH3. Both sides, we are having CH3 in this. Only in the first 3 compounds, the OH is fixed. Okay. Now, for protonation, the oxygen atom which is having the lone pair should be more electron rich. Only then it will protonate easily. Okay. In case of phenyl, what is phenyl? C6H5 group. This ring C6H5. This is the phenyl ring, right? And here oxygen is attached. Oxygen is having 2 lone pair. This is option number 1. Okay. Phenyl group is an electron withdrawing group. It withdraws the electron pair of the oxygen shifts here, and the pi electrons which is located here, it will undergo resonance. So what happens because of this resonance? The electron density on this oxygen decreases. The electron density of this oxygen decreases. If the electron density decreases, then it will be more difficult to protonate, right? So this compound is more difficult to protonate. In case of hydrogen, here second compound, there is no such resonance kind of thing. The lone pair is still available. We can protonate. And in case of option 3, CH3 group, which is an electron releasing group, it will be more easy for protonation. And here also 2 electron releasing group we are having. This center becomes more electron rich and this oxygen can more easily protonate. Okay. So the one which is more difficult to protonate is option 1. It is again an NEET 2022 question. Okay, 22, yeah. So I think it's clear to everyone. Now we'll move on to compound number 11. The structure of intermediate A in the following reaction is. The structure of intermediate A in the following reaction is. So see here, isopropyl benzene is given, and this isopropyl benzene reacts with oxygen to give compound A. And that compound A on protonation or acid hydrolysis forms phenol and propanone or acetone. Okay, this reaction you will find out in the preparation of phenol part. They will have some reactions. Under that you can find out this reaction. Okay, so basically this oxygen, this undergoes air oxidation. The compound undergoes air oxidation here, and this O2 will go and get inserted between this CH bond. Okay, the CH bond. So if you insert this O2 to the CH bond, what you will get? And to this ring already, I'll write the structure once again like this. So CH bond is there, and two CH3 groups we are having. To this CH bond, we have to insert the oxygen. Okay. So what type of structure we'll get? We'll get COOH and 2CH3 will be present here. So this structure is given in which option? So it is given in option 3. Okay. So option 3 is the answer for this question. Got it? This is again an previous year NEET question, which was asked in NEET 2021. And now let's move on to the next question. The attacking electrophilic species in sulfonation of benzene is. So what is sulfonation? Again, it is an electrophilic substitution reaction, right? So let's take a benzene, and the sulfonating reagents are H2S2O7. Okay, H2S2O7. So H2S2O7 is nothing but oleum. So what is oleum? Oleum is fuming sulfuric acid. So we have to write like this. H2SO4.SO3. This is H2S2O7, and this is the oleum, which is otherwise called as fuming sulfuric acid. Why it is called as fuming sulfuric acid? So this SO3, sulfur trioxide. So this is a gas, right? So only the sulfuric acid part will be there. And from this sulfuric acid part, on heating this, from this sulfuric acid, we'll get SO3H plus as an electrophile. So this is the electrophile that is getting generated from this oleum. Okay. So this electrophile will go and attach to the ring. So we'll get C6H5SO3H. And the name of this compound is benzene sulfonic acid, and this process is called as sulfonation of benzene. Okay. Now who is the electrophilic species here? SO3H plus is the electrophilic species. So this species is given in option 3. So that is the answer. Got it? Okay. Now question number 13. Which of the following is not an aromatic compound? So for this, we need to know the rules of the aromatic compound. For a compound to be aromatic, it has to follow some rules, right? First, the compound should be cyclic. For a compound to be aromatic, the first rule to be followed is it should be cyclic. And second, it should be planar, or it should contain sp2 hybridized atoms. Okay, and the third thing is it should have conjugation. Conjugation means alternative double and triple bonds would be present. And fourth rule is it has to follow the Huckel's rule. So what is Huckel's rule? Huckel's rule is 4n plus 2 pi electrons. 4n plus 2 5 electrons, where n value ranges from 0, 1, 2, etc. So these are the rules. You see here in the first compound, is the compound cyclic? Yes, it is cyclic. And all the atoms are sp2 hybridized because all the carbon atoms are doubly bonded, and it involves conjugation also. Sulfur is having two lone pair, and one of its lone pair will involve in the conjugation. Okay, alternative double bonds. And it follows the Huckel rule also. If you put n is equal to 1, you will get 6 pi electrons. Here you see for delocalization purpose, 1, 2, 3, 4 and 5, 6 electrons are involved. So it is following all the 4 rules. So this compound is aromatic, which is not the answer for this question. And coming to option 2, just check whether the compound is cyclic. Yes, it is cyclic. And check whether it is sp2. No, it is not sp2. We do have 6 carbon atoms here. Only 4 carbon atoms, 1, 2, 3, 4. And these 4 carbon atoms are having the double bond, which is sp2 hybridized. This compound number 5 and carbon number 6, carbon number 5 and carbon number 6, these two, they are not having double bond, or the hybridization of these two carbon is sp3. So it is violating, this compound is violating the second rule. So it is not an aromatic compound. Okay. So that is the answer for this question. And you can check with compound number 3 and 4 also. Compound number 3 is the cycloheptatrienyl cation. It is cyclic. It is sp2. All the atoms are sp2 hybridized. And you can ask, this carbon is not having double bond and all. But it is a carbocation, right? The hybridization of a carbocation is sp2. So all the atoms are sp2 hybridized carbon atoms. And the delocalization, this conjugation also takes place. And for this conjugation, 1, 2, 3, 4, 5, 6 pi electrons are involved. So it is following the Huckel's rule also. Got it? So this compound is cyclic, sp2 hybridized, conjugated with 6 pi electrons. So this compound is aromatic. And coming to this, it is same as that of the first compound. Oxygen belongs to sulfur group, same as that of sulfur. Oxygen also contains 2 lone pair of electrons. Electrons involves in the delocalization. The compound is cyclic. It is sp2 hybridized. Conjugation involves 6 pi electron, and the compound is aromatic. Okay. Is this clear to everyone? Option 2 is not an aromatic compound because 2 of the carbon atoms are having sp3 hybridization, which is not following the second rule. Got it? Good. Now we'll go for question number 14. Among the following compounds, the correct order of reactivity towards electrophilic substitution reaction is. So 3 compounds are given. And we have to find out which is more reactive for electrophilic substitution. Who are these electrophiles? Electrophiles are electron deficient species. If an electron deficient species has to come and substitute, the compound should be electron rich, right? So we have to find out which among the following compound is electron rich, so that it will be more reactive for the electrophilic substitution. Because only electrophile reacts with the nucleophile. That is, only electron deficient reacts with electron rich. So you see here, in all the 3 compounds, the ring is common. In the first case, OCH3 I already told, it is an alkoxy group, which is an electron donating group. And here, in case of benzene, hydrogen is located. And in case of the third compound, nitrobenzene, this nitro group is an electron donating group. Okay. Sorry. Nitro group is an electron withdrawing group. Nitro group is an electron withdrawing group. So this compound is electron deficient. And this compound, first compound is electron rich. And what about the second compound? It is intermediate between both. Only electron rich reacts with electron deficient. So compound 1 is more reactive. Then comes compound 2. Then comes compound 3. Okay. So here it is given in option CH3. So option 3 is the correct answer for this question. Got it? And coming to question number 15, which is the last question for today's class. And the question is the final product of the given reaction. So who is the reactant given here? It is phenol. Phenol on reaction with NaOH and CHCl3. So what is the name of this reaction? We all you have studied this reaction. So the name of this reaction is the Reamer-Tiemann reaction. This is called as Reamer-Tiemann reaction. So in the Reamer-Tiemann reaction, we get orthohydroxy benzaldehyde. We get orthohydroxy benzaldehyde. So who is orthohydroxy benzaldehyde here? Ortho means adjacent position, right? In the adjacent position, OH should be attached, which is an hydroxy group. So orthohydroxy, and this part is the benzaldehyde part. So this is the compound you will get from this reaction. First, it will form an intermediate. Phenol on reaction with this NaOH, it forms O minus Na plus kind of intermediate, and here CHCl2 will go and get substituted. Then on hydrolysis, will get, then on hydrolysis and reaction with water, will get this orthohydroxy benzaldehyde. What is benzaldehyde? Benzene attached with CHO is called as benzaldehyde. In the ortho position, that is adjacent position, if OH hydroxy group is attached, it is orthohydroxy benzaldehyde. So this is the product we'll get ultimately from the reaction of phenol with sodium hydroxide or potassium hydroxide with chloroform, okay, which is otherwise called as Reamer-Tiemann reaction. So got it? So that's all for today. So just go through the questions again. And if you have any doubts, you can let me know in the upcoming classes. Okay. So thank you students. Thank you everyone.